Hi everyone. So today I am going to introduce our solution to a blockchain-based coupling system that has potential to reshape our daily commute and significance to reduce the carbon footprint, which is the blockchain-based coupling system. So I'm gonna give a brief introduction. So in recent years, the rising popularity of lift sharing services has represented a more efficient mode of transportation, fostering community benefits, increased resale values, cost reductions, and social network expansions. But the traditional sharing faces lift sharing faces challenges due to reliable on centralized technologies and intermediaries, leading to transparency issues. So decentralization, which removes the need for central authority promoting trust and transparency, it also enables direct peer-to-peer transactions um, without increased intermediaries. So in this blockchain-based coupling system, we talk about smart contracts, which automate trade sharing agreements through self-executing smart contracts, and they also ensure secure and transparent transactions with predefined rules. We also talk about tokenization, which introduces a native token for transactions within the ecosystem. Um, we also have privacy and security, which utilizes advanced encryption um, techniques to protect user data, and it also ensures that anonymous transactions, ensuring user transparency, so the user and the driver are safe at all conditions. So the benefits of this are, let me talk about the background first. So the background in our rapidly, let's say, urbanizing world, traffic congestion and environmental concerns have become critical issues. Um, Traditional coupling systems have offered some relief, but they often face challenges related to scalability, trust, and transaction efficiency. So the blockchain-based system leverages blockchain technology to address these issues, providing decentralized and secure solutions, which the key points I've talked about earlier, like decentralization, tokenization, smart contracts, privacy and security. So, so in conclusion, the blockchain system offers a streamlined and secure approach to tackling urban transportation challenges by embracing blockchain technology. So we aim to create a future with where commuting is not only efficient and cost effective but also environmentally possible. Thank you. I am Mokisa Marvin, and I'm sorry that I have no power right now, but I had to record this. So I'm gladly. My next colleague will take you through the background. So these are the congestion cost in some US cities, which are the scorecards underscores issues of traffic congestion causing economic ramifications as demand surpasses our road supply. So we have a problem approximately 7 annually, which is lost. So the my next colleague is going to take you through the problem statement. So thank you.
Hello, I'm Balinda Robert, presenting on behalf of my group for the blockchain-based carpooling system, and I'm here to do the problem statement. So it goes as follows. I've noticed that existing carpooling systems lack critical travel details, leading to security concerns for passengers. Moreover, the heavy reliance on individual drivers in traditional methods poses limitations and risks, especially in terms of safety. So, additionally, the proposed demonstration includes motor locks as hacks drivers are used in this show. When there's a conversion auto with motorists, there are severe limitations. So basically, that's what our system is about, and we do have our scope. We do have the geographical scope and the technical scope. So the geographical scope, we are mainly focusing in central Uganda, that is Kampala, Rubaga, Entebbe, Mengo, and some other areas around the central region. This is because it is cheaper to us because we can be there physically, so it can fit our budget, and also it won't be time consuming. For our technical scope, our application is going to be web-based, and it will function with a well-established internet connection. So that would mean it is easily accessed by all computers or by any smart device. Um, the justification for our program, in Uganda, we are facing challenges like increasing traffic congestion, rising pollution, and high transportation costs. So these issues are affecting our daily lives and the environment. However, a blockchain-based carpooling system should significantly help by reducing the congestion, cutting down transportation expenses, and enhancing safety for everyone involved. Plus, this initiative aligns perfectly with the Uganda government's goal of promoting sustainable development. So, by introducing this innovative solution, we are just not addressing the current problems, but we're also creating new opportunities for job creations, and crucial for our nation in growing and developing. So at this point, I'll hand over to my colleague to take on the next part.
Yeah, good afternoon. Just as my colleague, I'll take you through the remaining parts. So I'll go to the objectives. I'll go through the objectives, related works, and loopholes in the current systems. So in the objectives, we have the main objective and a specific objective. In the main objective, our main objective is to develop a blockchain-based carpooling system that addresses trust, transparency, and security issues, thereby revolutionizing the way people commute and promoting eco-friendly practices. Then our specific objective is to create a decentralized and secure platform for carpooling, ensuring trust and transparency among users. To implement a tokenization system that initiates users to participate in carpooling. Tokenization is like payment. Then to develop a user-friendly interface that encourages widespread adoption. Then to promote eco-friendly commuting and reduce traffic congestion. Those will be our objectives. Then the related works. In 2012, Lyft founded. In 2012, Lyft was founded in 2012 in USA and is Canada-based ride-sharing service offering Lyft Standard and Lyft Line, recognizable by a pink mustache logo. Lyft provides a user-friendly app and a trust-based rating system. Then there is also BlaBlaCar, established in France in 2006. BlaBlaCar specializes in long-distance carpooling, connecting drivers on intercity journeys and passengers. The platform emphasizes trust building through user profiles, ratings, and reviews. Then Uber, this is common because it's been being used there in Uganda. It was established in 2009. It's a global ride-sharing giant with a user-friendly app offering services like UberX and UberPool. UberPool is like a geographical region where very many Uber cars are located. Should I say, like how you may see a pool of something, like a pool, a collection of multiple things. Its real-time tracking and upfront pricing and reputation systems are the key features that it has. Then the loopholes in the existing systems, like the ones that are existing, for instance, Uber is the main one that we targeted. Limited accessibility. This is common because in villages or rural areas you can't access Uber. Or even the app will run, but they will show you that there are no drivers that are located in that area. Then also limited data privacy. This is because some users don't feel like their data should be shared. That is their location where they are currently, and also they don't believe in showing their, like putting in their login details in those various applications. Then competition and market share. There are very many car providing systems that are, because you have Safe Border, Uber, so all these face competitions from each other, and here it leads to shortages and price drops. And also poor surge pricing mechanism. This is because in some areas someone may put in like in an app when he wants to go in a given place, and we find that different people are taxed differently depending on the time in the day. So this is a big loophole in this system. Then also legal and the regulatory issues. This is the government. The government can issue commands on how to drive different cars. So this is all from me.
Greetings. My name is John Matthew. My previous colleague took us through the different loopholes. We mainly gave the loopholes in Uber, but they relate to all the different research gaps that we made. So I'm going to take you through the methodology. Our methodology states we're going to do data collection, and they have stated some of the programming languages we are going to use. We plan to, with the data collection, we plan to use observation, document reviews, focus groups and interviews, and survey and questionnaires or blockchain transaction records that are going to be stored in the different accounts, both of the account of the user and the account of the driver on the different trips they have taken. So with the survey, we have designed a survey tool that will help us integrate through our data analysis and see how the project will be useful, or it will impact the environment or the surrounding. Then in the programming languages, we plan to use Solidity and Ethereum blockchain. Since Ethereum blockchain is secure, then we plan to use non-fungible tokens like we plan to use Ethereum itself, or we plan to use such tokens. Then with our system architecture, as you can see from the drawing, let me take you through the system architecture. The app facilitates, first of all, it facilitates user registration and login through secure authentication using credentials or media accounts. Upon logging into the system, the passenger can request or initiate a ride matching algorithm that securely serves pickup and drop-off details that are stored in our database. Then user profiles comprising of different information like preferences, ride history are stored in a database that I'm talking about. Let me give you an insight of Uber. Safe Border. They have a section where they show you the different trips you've taken and how much you've paid for them. Then when the driver accepts a ride, the smart contract, including the deposit fee, acts as a verifier. Then push notifications provide real-time updates in the in-app messages that allows user communication with the driver. Then a zero knowledge proof enhances trust, validating the smart contract's outcomes. In case of the ride cancellation, in case someone needs to cancel a ride order, the smart contract is automatically released. It automatically releases the driver. Remember, for the driver to take up the offer of the of the ride, he has to make a deposit. Yeah, has to make a deposit that initializes a smart contract. Then another smart contract validates the entire journey, ensuring payment of full service fee to the driver. Then external data like latitude and longitude undergoes validating or validation by trusted entities before integrating into blockchain, maintaining the integrity of the system. So with our system, we are mainly providing integrity to our system. Then I'm going to take you through our proposed timeline. This is our proposed timeline, and we plan to finish our project before the end of this timeline. Yes, these are our references that we have used. Yes, thank you very much.